Three, two, one. And we are live. Hello, everybody. Welcome to the next session by Bartlomiej about concurrency control in REST API with Spring Framework. So, hello, Bartlomiej. How are you doing?
Hello, everyone.
Hello.
Thank you for the very warm welcome. I'm very happy to be here. I'm feeling fine. Apart from the COVID-19 situation, everything is okay.
Okay, I think the floor is yours. Attendees, please ask the questions. We are going to have a short Q&A after the talk. And Bartlomiej, the floor is yours.
Okay, thank you. So, hello, everyone, once again. I'm really glad that I can be here with you today. And I am also very sorry that I had to cancel my talk last year. I was supposed to be there with you in Minsk. And I hope to see you all in Minsk or in Tallinn this year, but all this COVID-19 situation changed our plans. But I hope that you all are healthy now. Today we are going to talk about the impact that concurrency control can have on our APIs. And in modern software systems, it is not uncommon to have like hundreds or thousands of users independently and concurrently interacting with our resources. And we generally want to avoid situations when changes made by one client are overridden by another one without even knowing. And in order to prevent our data integrity, let's say, from being violated, we often use locking mechanisms provided by our database engine, or even use abstractions provided by tools like JPA, for example. Now, the question is, how does concurrency control impact our API? What error codes do we use? What headers do we use? Or does HTTP protocol support such cases at all? And finally, how to implement our APIs according to ART with Spring Framework. And during this talk, we'll answer all these questions. What this talk will not be about. We won't be talking about locking, isolation levels, transactions. We'll just focus on modeling the API. And so that you know who's talking to you, who's going to talk to you for like 40 minutes, I'll make a short introduction about myself. My name is Bartlomiej Slota. I come from Warsaw, Poland. I'm a software engineer. I'm a consultant, mentor, trainer at Bottega IT Minds, and I am also a public speaker. I blog from time to time, and I've gained experience working in numerous industries, starting from healthcare through telco, marketing, finance, energy, for companies of different sizes, like from tens to thousands of people. And I'm very passionate about OP, domain-driven design, software craftsmanship, microservices, and everything that is somehow related to software architecture in general. And in my personal life, I'm a husband, a father. I love heavy metal music. I used to have hairs like that long hair. I love guitar playing, angling, and trekking. And it's high time we started the presentation. Let's start with the use case that we are going to work on today. And this use case is the automated process of placing book on holds by patrons' clients in a public library. And for the sake of simplicity, let's assume that each book can be in one of two possible states: available and placed on hold, which in other words means that reserved. And a book can be placed on hold only if it exists in the library and if it's currently available, of course. And this is what you can see on the screen. This is how it could be modeled during the event storming session. And each patron can place the book on hold, send a command in order, but in order to make such a decision, he or she needs to see the list or some details of available books first. So view read models, in other words. And depending on the book availability, we will either allow or disallow the process to succeed. So now let's have a look at the code now. I hope the font size is fine for you. We won't be walking through the whole application. There are lots of classes here, but we'll just focus on those that are most important from the perspective of this talk. And the first thing that we are going to look at is the book holding controller, which basically exposes a patch method for /book/book ID URL. And what we are doing here is that we are expecting to have some command that is about to change the status of a book. And if we are trying to set the status to place on hold, then we execute this placing on hold, this reservation logic, we can say. And what happens underneath is that we are forwarding the processing to our application service, which under the hood gets the book from database if it exists, of course, do what's necessary, and persist the result in the database. That's basically it. And for the sake of simplicity, we do not care about any other scenarios that may happen in this case. What we do also have is the book finding controller. And in this controller, we basically have a get mapping so that the customer can see the details of particular book. And here we just return the read model. And regarding the book holding controller, one more very vital thing is that in case the book placing logic ends up successfully, we return true for status code, which means no content. And what we also do have, and what we will utilize during this talk, is the book API test. All these things that we just discussed are tested and covered within this book API test class. But before we dig deeper into the code and start making something with it, we need to identify the problem first. So it might be the case that two patrons are watching the list of available books at the same time, and they both see that the same copy they're interested in is available, and both of them are trying to place the book on hold at kind of the same moment, let's say. So how can we handle concurrent access in our application? Well, in the moment of saving the updated book in the database, we could make a full state comparison with what currently resides in the database. So if the result of the comparison is positive, we can persist the new version of our aggregate in the database. And these operations, I mean, comparing and updating, need to together create some atomic operation. And the advantage of this solution is that it does not impact the structure of our aggregate. It doesn't leak into the domain layer or any other layers. But this is not something that we are going to work on today. Alternatively, we could use locking mechanisms like pessimistic or optimistic locking. And without going into details, the latter one is preferable when the number of write operations is not that big comparing to read operations. And optimistic locking lets every client read and write data at will, with the restriction that just before committing the transaction, we need to simply check if a particular record has not been modified by someone else in the meantime. And how it's usually done? It is usually done by adding some current version attribute or some last modification timestamp attribute. And here I would like to point out that one thing, that what I have been observing, I don't know if it is your observation or not, but what I have been observing throughout these years is that when dealing with concurrent access, we usually think of the technical side of the problem only. But is concurrency control a technical problem? Let's imagine a conversation between a developer, a lady on the left, and a product owner, or maybe someone from the business, the man on the right. And let's imagine the developer says, like, let's talk about circumstances where two patrons try to place the same book on hold and only one wins. Is there a situation in which we simply cannot tell our user that she had a bad luck trying to place the book on hold? And someone from business could say, yeah, when the patron is a premium one, you should send an email to me and I will contact him directly, or I'll try to find a copy for him, or I will cancel some other patron's reservation, or whatever else. So this is a very, very simple example of how we could approach the problem. And I really encourage you to always think of the business rationale before choosing any technical solution, because we as developers often think that, okay, there might be concurrent access problems, so I will just implement everything what JPA provides me. I will provide optimistic locking. But what really happened, or should happen, is that we should first have a full understanding of what are the business needs for this particular cases. Okay, let's assume that we chose optimistic locking to secure ourselves from lost updates. What is the impact of the on the API? Okay, so let's get back to the code again, and let's switch to another revision. Check out optimistic locking, and what we can see now is that we have some version class which is created for the purpose of implementing, let's say, optimistic locking over here, and this is basically some wrapper around a version value, we could say, some value object, some object that encapsulates the value of a version. Where do we use it? We can use it, for example, in our domain logic, in our domain classes, where, and for example, in available book, we could add a version attribute. And we propagate this attribute down to the persistence layer. In our case, this is a book entity. And in book entity, we also do have some version attribute annotated with the version annotation. And with such a setup, the JPA implementation will take care of the optimistic locking. So far, so good. Nothing special is happening here. But the question is, what do you think will happen when the conflict occurs? And the answer is included in one of our classes over here. Optimistic locking failure exception is going to be thrown. Well, we can map it, of course, into some more meaningful exception of ours, like stale state identified for aggregate with some ID. But still, until we do something with this exception, what Spring Framework will do is that it will return 500 internal server error response to our customer. And it is definitely not something that our customer would like to see. And knowing it is a possible business scenario that two patrons try to place the same book on hold, should it be treated as an error or even as an exception? Not really. But unfortunately, this is where the concurrency control usually ended in the projects I've seen. So, assuming we want to tell our customer that we are sorry that we couldn't make the reservation due to the conflict, using 500 internal server error really forces us to put some extra information in the response body so that our client can, read this information and try to find out what really happened. And there would be some information about, all right, there's some conflict, right? But fortunately, there's a standard solution for the problem. And what is the solution? The RFC 7231 about semantics and context and content of hypertext transfer protocol introduces the 409 conflict response status. And just let me read a little fragment of it. So the 409 conflict status code indicates that the request could not be completed due to a conflict with the current state of the target resource. This is exactly what we need, right? This code is used in situations where users might be able to resolve the conflict and resubmit the request. Okay, so good so far. The server should generate a payload that includes enough information for a user to recognize the source of the conflict. All right, what does this really mean? Let's explain it by example. We'll move to yet another revision. Let's check out. And this time, we'll start by looking at placing on hold conflict test. And what do we have here? Let's imagine that we have some available book in the system. Then we read this book. I mean, we are sending the GET request. And then in this book view, we have a version attribute, you see. So we read the book and we think that we are working with particular version of our resource. And in the meantime, the book is modified by someone else. So whenever we try to send the placing on hold command, then we expect to get the status equal to 409, conflict status, right? But apart from the 409 response code, we also expect to get the current state of the resource. You see, all this information that are necessary for the customer to understand what is the reason for the conflict, in practice means that we are returning the current state of our resource. And by the current state, we mean, I don't know, ID, title, whatever it is, and also the version attribute. And please note that here in the last line, we do not care about the exact value, because in the context of REST controller, we do not and should not even care about how this attribute is calculated or updated. We only care about the fact that it changed, that it changed, right? So this test does not pass. So how can we make this test pass? Let's open the book holding controller. And like I said at the very beginning, we have some application service over here. And here we have a method that really handles the command. And as you remember, we are throwing here a stale state identified exception. So what we could do here is that we could create some controller advice and catch this exception and return some error code then. But as we also already discussed, this is not an exceptional situation. This is not an error. This is a valid business use case, that there is some conflict, right? So it is way more readable to express it explicitly here. And if we have a look at the result interface here, we have a couple of implementations. We can signal that the book was successfully placed on hold, that the book was not found, and also that the book conflict was identified. And this is something that we are going to return as a regular response. So what we can add here is that we could surround our code with try catch like this, and we need to react to stale state identified exception. And what we need to do here is that we need to return new book conflict identified result. And what we need to put here is also the current state. And what is this current state? It is what really resides in the database right now. Current state, book repository, find by book ID, and for the sake of simplicity, let's return null if we do not find it, or else null. All right. So if we run the test now, we are not done yet, because now we return the result. Now it's high time we do something with it over here. And if we have a look at how we are building the response, you see that what we have been reacting to is only the success, the book not found, and all the other cases return the 500 internal server error. So what we also need to add here is else if, for example, result instance of book conflict identified. And here we also need to, of course, build the response entity. So return response entity with status of conflict. And we also need to put the body over here. And in order to do so, we need to cast our result into book conflict identified result. We need to take the current state of it. We need to map it to our view model, let's say, view from, or else, again, for the sake of simplicity, let's return a simple null. So let's run the test. And in the meantime, when the test is being executed, we can continue our discussion. So if a customer gets 409 response, it needs to interpret the status code and analyze the content in order to determine what might have been the source of the conflict, right? And according to some other RFC, 5789, as far as I remember, these are the application and the patch format that really determine if a consumer can reissue a request as it is, it can recalculate the patch, or it simply needs to fail. And in our case, we are not able to perform the retry of the message preserving its form. And the reason behind this is that the version attribute has changed, right? And even if we apply the new version before resending our message, we need to also check the source of the conflict. And if the source of the conflict is that the state is changed to place on hold, for example, and the book is no longer available, we just cannot reissue the request. We can see on the screen that the test passed, so everything is fine. In this solution, the main and the API must contain the version attribute. So If the domain has a notion of a version, it's fine. Otherwise, the code might get a bit dirty, but I usually approach this pragmatically, right? An alternative could be to use timestamp of the last modification of the resource, which might have a bit more business meaning sometimes. All right, but I wouldn't invite you to a talk just to tell you that in case of conflict, we can map the exception to 409 error message, right? So we have a solution, but is this all we can get from HTTP? So let's take a look at the other example once again. Aren't we executing a request that is conditional? Yes, we are, because we allow our clients to update the book only if it has not been modified in the meantime, if it has not been placed on hold by someone else. So it turns out that, again, there's an explicit and standard way of dealing with conditional requests in HTTP protocol. In RFC 7232, we have a definition of conditional requests. And conditional requests are HTTP requests that include one or more header fields indicating a precondition to be tested before applying the method semantics to the target resource. And this RFC also distinguishes conditional read and write requests. The former ones are often used for effective caching mechanisms, so we'll focus on the latter ones because we are using the unsafe methods in our case. And the very basic component of conditional requests is called an E-tag, entity tag header, that should be returned anytime we read a resource with GET requests or we update it with some unsafe method. So E-tag is an opaque textual validator token, we might say, generated by the server that owns the resource and is associated with some particular representation at a given point in time. So the idea behind E-tag is to enable the unique identification of the state of the resource. And ideally, every change in both entity state, which is the response body, and its metadata, content type, should be reflected in the updated E-tag value. And one could ask here, why do we need E-tags when we have last modified header? The problem is that last modified header schema limits the time resolution to seconds only. So in case of dealing with concurrent access, seconds resolution up to seconds is just not enough. So we simply cannot rely on it. Okay, we'll start describing E-tags from the validation, from how we validate E-tags instead of generation, not by accident. The way in which we create this header depends really on a chosen way of validating our preconditions. And there are two types of validations. The first type is the default one. It is called strong validation. And the second one is weak validation. An entity tag is considered strong when its value is updated whenever the content of particular resource representation changes, and it is observable in 200 OK response to some GET request. And it is crucial that the value is unique between different representations of the same resource, unless the representations have identical form of serialized content. And of course, the problem is gone when we are supporting only, for example, application JSON. So then we only care about the changes in the body, in the content of our resource. And on the other hand, entity tag is considered weak when its value might not be updated on every change of the resource representation. Why can this ever happen? So the reasons for using weak tags might be dictated by limitations of the algorithm that calculates them. And as an example, we could take timestamp resolution, for example, or just inability to ensure uniqueness across different representations of the same resource. Which E-tag should we use? It depends. Strong E-tags, they can be difficult to generate efficiently. Weak E-tags, however, are considered easier to generate, but they are less reliable in terms of resource state comparison. The choice should be just dictated by the specifics of our data, let's say, the types of supported representation media types, and what is most important, our ability to ensure uniqueness. Okay, E-tags are generated according to the formula you can see on the screen. So E-tag is just a concatenation of the W/weak validation indicator. We can say that is optional. So whenever we go for weak validation, we just add it. If we are using strong validation, we just skip it. And of course, we also need to put the opaque tag value there. And the opaque tag always needs to be surrounded by quotes, but double quotes. Some examples, you can find some examples on the slide of how this E-tags could look like. But the question is, what should we put into the opaque tag? Well, we should put there anything that enables the unique identification of the resource in its particular representation. What can it be? A version number combined with some content type classifier, a hash value calculated from the content's representation, sub-second resolution timestamp. These are just a few examples. Okay, so what do we need to return E-tag headers in our application? So let's move to another revision. Git checkout doc entity tag. Okay, let's start with book API test again. And what you see here is that we already have a test written that does not pass. Should include E-tag based on version in book view response. So whenever we have some available book in the system with some particular version, and we try to read it from our API, so if we're trying to send the GET request, then we expect, apart from getting all the body and the 200 OK response status, we also expect to get the E-tag header, which contains the version surrounded by double quotes. How to do this? Let's move to the book finding controller, and we need to update the response entity. And it turns out that we have a very fine way of doing it, because we have a method in the response entity builder called E-tag, and we can simply put it here. So string value of, in our case, it's get version, and we are done. And this part of the API is usually used for caching purposes, but you can see how easy it is in Spring Framework to include the E-tag, and we don't have to worry about adding this how do we call it? I missed the word. Yeah, never mind. I missed the. You know what I mean. We don't need to worry about this at this point. So now if we run the test, quotes, I meant quotes. Yeah. Test is being executed. Let's continue. Having the E-tag value returned, we also no longer need to pass the version in the response body of the movie, because now we are using the HTTP header for this purpose. So, all right, we know what E-tags are. We know how to calculate them, how to compare them, and now it's time for a conditional request, because what we do have now is only some information about the entity version, the version of our aggregate. So how can we create conditional requests? Let's move to the let's make this test execute, and let's move here. The RFC 7232 defines headers that we define conditional requests, and these headers are listed here on the slide, but those headers that are relevant from the perspective of unsafe methods are Ifmatch header and if unmodified since. But since we are not working with dates, in our example, we will utilize only the Ifmatch header. So if we want to execute conditional requests, we need to put either Ifmatch or if unmodified since header in our unsafe method. All right, but regardless the header we are going to use, we need to know when should we evaluate conditions embedded in these headers. Here's what we can find in the RFC. A server must ignore all received preconditions, if its response to the same request without those conditions would have been a status code other than 200-ish or 412 precondition failed. So what does this really mean? It means that if we have any validations on the server side that end up in, for example, 404 or 422 unprocessable entity or any 400-ish messages being returned, we should perform these validations first. And we also need to remember, though, that precondition checks must also take place before applying the actual method semantics on the target resource, right? Okay, so we mentioned that we are going to use the Ifmatch header. And the idea of the Ifmatch header is to give the server information about what representation of particular resource the client expects to have. So in our case, it could look like this. Whenever we send a GET request, we get a response, we got information about the book, its status, etc., and we get the ETAG header. Okay, that's clear. And then we can, when we are executing the unsafe method, we have two alternatives. The first alternative is to send the correct ETAG value. So we send the patch request with proper body, and we also include the Ifmatch header with the value that is equal to the ETAG that we got before in the GET response. Right, and then if everything's fine, the Ifmatch header value matches the ETAG, the version of our aggregate, then we simply get 204 no content response. But if we put the incorrect value, then we should get 412 precondition failed. All right, so it is high time we put it into the code. So, okay, the test from the previous exercise passed. Git checkout talk if match. All right, and again, we have some tests written already. API test. Okay, over here, and now we have two test cases. First, should successfully place book on hold. So if we have some available book in the system with some version, then we read the book. Okay, we read this book. We read the body of the response, and we also read the ETAG header value. And if we try to place the book on hold, we create the command, and we use this Ifmatch header that is equal to the ETAG that we got before, we expect to get no content. This is exactly what you could see on the web sequence diagram. And second case is that we should signal precondition failed. So if we have some available book in the system, and we are trying to use some stale ETAG, and we put the stale ETAG here to our request, then we expect 412 response. So now it's high time we coded it. Book holding controller. Here's the place where we need to make some changes. We have not spoken about forcing our clients to use preconditions. So in order to keep the backward compatibility, we'll add second method that will intercept all patch requests that contain this Ifmatch header. So what we need to put here in the existing method is something like this: headers, and we do not expect to get Ifmatch header. Okay, so now we will copy the whole method. Don't worry, we'll get rid of the duplication a bit later. So now we expect to get this header over here, and we also expect to get request header named Ifmatch HTTP headers. If import class from Spring if match. Okay, all right. And now I'm going to use class of type ETAG, and it's called Ifmatch. Now you're probably wondering, what is this ETAG? Is it something provided by Spring Framework? No, it is not. Spring Framework do not provide it, as far as I'm concerned. So we could, of course, use string here and put all the logic into our controller, but I already provided this in my project, so feel free to look at my GitHub project. Everything that you see today is already on GitHub. You can freely use it for your own purposes. So this class encapsulates all the logic related to ETAG, so including serialization and deserialization. So it is very convenient to to have such a class that encapsulates all the fields and adds some let's say helper methods. What do we need to do with this Ifmatch? We need to create a version, because we know that our entity tag is equal to our version. Of course, we need to do some parsing here. Version from long, parse long, and if match, we get some trimmed value, and that's all. Okay, we have a version. And what to do with this version? Okay, so we are no longer interested in the version that is included in the command, but now we are looking at what is placed in the header. So this is it. Okay, but we also no longer want to return the conflict status. So for the sake of simplicity, again, I will just make a copy of this method. I will quickly rename it like build conditional response from, and now we no longer need that kind of stuff. We return status, and now we are going to return the status equal to precondition failed. Precondition failed, build. And if we get back to our book API test, I'll run all these tests, and we'll let them run. And not to waste too much time waiting, let's continue our discussion, because here we reach the moment when we have two methods, two different kind of ways of handling concurrent access. Now we need to decide whether we want to keep these two solutions running in parallel or not. And the question is there a way to force the API clients to use conditional requests? And it turns out that there is. RFC 6585 introduces some additional HTTP status codes. And one of these codes is 428 precondition required. And this status code indicates that the origin server requires the request to be conditional. And its typical use is to avoid the lost update problem, where a client gets a resource's state, modifies it, and puts it back to the server, while in the meantime, a third party has modified the state on the server. This is exactly what we need in our case. Because we have only like 3 minutes left, I will just show you the result. Oh, some test failed, some signal precondition failed. All right, no worries. It's sometimes happen when doing live coding, but I'll show you the exact result, the end result here in the last let's say revision. Git reset, git checkout, talk, preconditions required. Okay, and if we have a look at book holding controller once again, what you saw there is that we had the Ifmatch header that we expected as a parameter of our controller method, but now you see that we are no longer making this distinction for two methods, one expecting the Ifmatch header, second one not expecting the Ifmatch header. Now we just say that this ETAG is not required, and thanks to this, if it's there, we can handle the request just the way we did last time, and if it's not there, we can return the precondition required status. All right, this is how it could be done. And just to sum up this last part of what we've been discussing, is that whenever we send the GET request and get the ETAG, if we do not include this ETAG value in any of conditional request headers, here we should get 4 to 8 preconditions required. Okay, we have 1 minute left, so it's high time we summed up the presentation. Concurrency control should be reflected by our API, especially because HTTP provides a set of tools to support us. The first thing to start with is to add version attribute into our read mode and pass it further to our unsafe methods. And the simplest option for handling conflicts is to return 409 conflict status when the conflict is detected. A bit more sophisticated solution is to use entity tag header or last modified header, if we like, and their values should be put by clients into Ifmatch header or if unmodified since headers respectively. And In the case of the conflict, we can return 412 precondition failed. And we can also force our clients to use conditional requests by returning 428 preconditions required. And what you could also see is that Spring Framework supports us in returning ETAG headers, but we have to implement unsafe conditional request handling on our own. Fortunately, the API is pretty powerful, so Spring Framework enables us to do so. And I really recommend you, if you're interested in digging into this topic, I recommend you and encourage you to visit my homepage, bartlomiej.com, where I have a blog post about this that fully describes our example in detail. And of course, in my GitHub account, you will find this example, and the full code is also there. Thank you very much for attending. Thank you very much that you stayed until the end. I saw that the number of participants stayed the same, almost the same throughout the whole presentation. So I hope you were not too bored. Thank you very much, and take care and stay safe. Thank you very much.
Thanks, Bartlomiej, for this session. It was very interesting. I'm always fascinated how easy it is to build stuff with Spring Framework, and it's really nice to see it live with the live coding session. Unfortunately, we don't have any questions from the audience. Probably it was so engaging that people just didn't have the idea of what to ask.
Yeah, I'm also aware that there are many information, and we sometimes need to sit in silence for like 15 minutes to read through it again,
Right.
and then it all becomes clear. So I fully understand. So
no, we have a question now. We have a question.
Oh, okay.
First and only, would you suggest doing so for all shared resources or just for the most important ones? Because doing it for all resources would complicate the development a lot.
That is a great question. I think I answered this question during this talk, because I said that every technical decision that we make should be driven by the business requirements. So if the probability of the concurrency control conflict is very, very low, I wouldn't spend force on doing this on such resources, because if it requires like one update on the database a year or half a year, it is not worth doing anything in your code, because it would complicate it. Like you said, it would complicate development a lot. So I would do this only for these resources that are really in danger in terms of the concurrency access conflicts. That's the first thing. And the second thing, if we need to do something more about this situation, like we also mentioned, if we are not only going to tell our customer that, okay, we're sorry because there was a conflict, but we need to do something else, like send an email to someone, then definitely this is the place where we should use it.
Yeah, basically keep it simple, keep the complexity where you ain't gonna need it.
Yeah.
Right. Okay, then it seems we're out of questions. It was the only one, and thanks, Kirill, for asking it.
Thank you very much.
So it was very interesting, and let's have a break now. We have a next session in a few minutes.
Good. Thank you very much. See ya.
Bye. And we are